Good morning, everybody. So what we're going to do today is we're going to start to install, or hopefully not start, hopefully we're going to finish installing a DRO kit on my Precision Matthews PM-1228 lathe. So why do we want a DRO kit? What's the benefit? So if any of you have been watching any of my milling videos, milling machine videos, I installed TouchDRO on my vertical milling machine. One of the benefits of that is that you no longer need to count and keep track of hand wheel movement, right? So here, or here, or here, or here. You also no longer have to keep track of the backlash that's inherent to those mechanical systems, which can be a pain in the neck if you're not careful. So I consider a DRO on a mill kind of a non-negotiable item. You kind of need it. When I started milling 20 years ago and took a 20-year hiatus, those DRO kits were very expensive. Now they're much more affordable. So you can get the DRO scales for a lathe for roughly $100 or so for the cross slide and the Z-axis. And then you need a tablet and a computer to read the inputs from those scales. So let me show you what I purchased and then we'll talk through the installation. All right, so what do we have on the table? It's a little messy, I apologize. So here we have our TouchDRO computer. Give you details to where you can buy all this stuff in the description as usual. So this is actually made by a machinist himself who likes to design electronics. You buy this whole kit right here, which comes with a cable, a little manual, and you can download and install a free app from the either, I think is it iOS only? Is it only Android or is it iOS too? It looks like it's both. Yeah, it might just be Android. You install an Android app on a tablet or a phone or some other Android compatible device, and your scales connect to these inputs here on the back, and this Bluetooth to the tablet. So pretty cool. We'll get into that a little bit more later. And here are the two scales. Full disclosure, these scales are probably a little bit too big. I didn't want to risk undershooting the travel of this lathe, so I probably went a little bit longer than I need to. And also, full disclosure, I've never done this before. I'm not a machinist. I'm just a hobbyist. I like doing this stuff, so you're probably not going to see any high-quality machine work or anything like that. So if you're looking at this video to critique machining, you're looking at the wrong video, okay? Let's just get over that now. So the key to successfully installing these scales, again, this one goes in the cross slide, this one goes on the Z-axis, is adjustability. No matter how hard you try, no matter what you do, you will make mistakes. The mounting holes for these will not be perfectly aligned, and you'll notice that the mounting holes are oblong, so you have some adjustability if you look at this hole right here. You also need to make sure this read head is a fixed distance from the actual scale. This one didn't come with one, but they should come with these little adjusting strips. Right here you see a little orange spacer right there. It's not an adjusting strip, it's a spacer that spaces this read head away from this optical scale. So again, this is the Z-axis, this is the cross slide. We have to mount, well, let me just show you. I think I'm going to focus most of this video on the cross slide because that's where the challenging part is going to be, because this is a small lathe. You'll notice I've already removed the compound, so now we just have our cross slide, right? You'll also notice that I swapped out this gib lock screw, which used to be this Allen, I think it's an M8 Allen head screw. I'll give you guys some more light. Hopefully that's better. I swapped this out because I don't think there wasn't going to be enough room for it, because the scale is going to mount over here, right? So let me get the scale and mock it up for you. And you want to mount these face down because you don't want chips falling in here, right? So you might be tempted to mount it like this. Don't do that. So if we take our cable here, I'm thinking it'll mount somewhere about like that, and notice it blocks that gib screw right there. So if we were to hit it with an Allen wrench. So if we swap it with a hex head, then we can get in there with a traditional 13mm wrench. So for example, if we wanted to get in here after our DRO is mounted, we just go in here, sneak under it we'll sneak into it from the side like that rather than from top, right? So I can go here and just lock the gib, unlock it, so on. So I think that's probably required unless you never want to be able to adjust your locks again without taking off the DRO, which I do not recommend. And again, I think it was just an M8 bolt. I had one laying around, didn't even have to go buy one. It's the exact right length, just a different head on it. So that's step 0, swap that out. What I also did is I cut a piece of aluminum strip here down to size, or approximate size of the scale. And we're going to be mounting this here. I'm thinking I probably should reduce the height of this a little bit though. It seems a little bit tall. Yeah, I think I'll do that. Because this is going to go here. And I don't think I want anything sticking up above this. I don't know, let me mull that over a little bit. And what we'll also have to do is drill and tap a screw here, and similar screws here and here to be able to mount this here. Also, going to need some spacers. I just 3D printed some just to mock this up. I'll probably end up using the lathe and cutting them out of aluminum, but be a spacer here and here. We'll probably be able to shorten these spacers though, because like these spacers were designed to allow enough room to access this as a hex cap screw, which it is not anymore. Now it's a hex head screw. So I could probably shorten these and bring the scale closer to the cross slide and save some travel on the lathe. So let me work on this a little bit off camera and I'll show you what the final product looks like. Okay, I'm all set up in the mill. Before y'all freak out, I know this is not an ideal setup. I don't have any machinist jacks. I don't have a second vise to support a part this wide. So I'm just gonna make do. Suppose I could clamp it on either side with some steel or something wider, but you know, this is not a critical part. It doesn't need to be super dimensionally accurate, so I'm just gonna wing it. My goal is basically just to make that black Sharpie outline disappear. That's where the scale was. So I basically just bolted the scale to this bracket and traced an outline of it with a Sharpie. So the goal here is to make the black disappear. And we'll do that just basically by eye. But I figured it'd be a good opportunity to show you TouchDRO. So let's get everything all situated here. Let's get the mill going. Let's lower us down a little bit. This brake is on a little. Whoops. I don't know why I was making that noise. All right, so we're going to raise the Z until we just start to see a little bit of a chip. So I'm just cranking the Z axis and the knee hand wheel, just raising ever so slightly. You can watch the TouchDRO measure or register the difference in the Z. And there's different ways to do this. This is just the way I'm doing it. It's not the most accurate, but again, we don't care. This part doesn't need to be super accurate. Okay, I'm just starting to hear something. Okay. So what we'll do is we'll go to TouchDRO over here. To kill this light. I think the light wasn't on. Let's 0 our Z. And now what we can do is we can measure and take off a very precise amount, probably within, you know, a thousandth or so. So let's crank up. I'm going to go in small bites just because this is not a terribly rigid setup that we have down here. So let's raise the Z like maybe 5 thou. And realistically, I probably could go a bit heavier, but no need. Yeah, 5 thou give or take. And let's focus on the actual machining. Here we go, let's go for it. Now if this is more rigidly set up, I'd be taking more aggressive cuts. And I am wearing safety glasses for anybody concerned. I know I take a lot of flack in the comments for inconsistent use of safety glasses. Probably crank up the speed a little bit. One of these days I'll pick up a X-axis power feed, but for now I'm just hand cranking. You can hear how the sound really changes once we get over a rigidly supported section. and back onto a not rigidly supported section. Slowing way down here. Yes, I know, chatter is bad. Back off. Go back the way we came. Actually, let's take it back. Let's go back this way. So we'll go back up to where we were, about 5. Let's do another 5 thou, bringing us to about 10. Let's go back the other way. That beeping that you hear is TouchDRO. It beeps when it reaches a 0, which it just crossed in the x-axis. Somewhere around there or so. Slowing down. Cool. Gonna do another 5 thou, give you a close-up, and then I'll do some more of this off camera. Let's bring it up to 20 total. It's a little bit more than 5 thou, but who cares? We're having fun, right? A bit of chatter from the not rigidly supported part. We'll just go slow and plow right through it. Cross to 0. I don't have the x-axis properly zeroed out because I don't really care, because we're just going the full length of the part. Now if I needed to stop turning the X or moving the X at a specific location, then I would zero it out and we'd be able to measure how far we've traveled, but it doesn't matter here. You guys get the idea. Probably a good first start there. Now let's change our setup. We're going to go from cutting that top there, we're going to go to cutting the sides. Let me vacuum up some of these chips. And for fun, let's zero out X here. I'm going to take out the cutter tool. I'm going to put in an edge finding tool. And we'll try to hit that dead center. Come over there, come down a little bit. There we go. So let's run this about, say like, keep on leaving that darn brake on. Let's turn this way down to like maybe 800 RPM. 900 is good enough. 850. So there's our tachometer signal right there. So let's do, bring it over. There's our 0. And then TouchDRO, let's swipe to the right, do edge finding. It's a 0.2 inch diameter edge finder. We'll do X on the right, set origin. So it automatically set our 0. So I did half of the diameter of the edge finder, which is a 100 thousandths right there. Let's swap out our edge finder. "20 years ago, I was used to one of those pneumatic things up here. I forget what they call them. I'm sure they have a name that someone will remind me of. Our end mill back in. Loosen that taper up a little bit. There we go. Now the center line of this end mill should be locked on to the edge of the part. Okay, after zeroing the part, you have to go into TouchDRO. I've already done it, but you have to go to tool radius compensation. So that's this function here. And I dialed in a tool with a diameter of 0.375 inches, which is the 7/16 inch end mill that I've been using. Set it on the right side, and that automatically figures out when the edge of the tool will touch the part. So for example, you can see that the TouchDRO reads about 70 thou right now, which is in theory that distance there. And if I bring it back, you can hear it starting to beep. 50 thou, 40 thou, 30 thou, 20 thou, 10 thou. It's like 6 thou right now. That's pretty darn near touching. So now if we start up the mill, it should be taking nothing off, because in theory we have a 6 thou gap. And then we'll bring it down to 0 really closely, and we'll see if it just starts to shave. And of course I forgot the brake again. One of these days I'm going to pop a belt. I don't have a spare. Okay, so nothing. Let's slowly bring it down to 0. We're at like 3 thou. 1. We're just about touching, so about a thou off. That could have been my edge finding error. All right. Let's sweep it front to back. And now let's take off, I don't know, we can take heavier cuts here because we are more rigidly set up than we were before. We bring the knee up a little bit. So let's take about 20 thou off. That should be no problem. Cutting like butter. Let's do another 20 thou. Whoops, a little bit more. Doesn't matter. Maybe one other light pass and they'll be done. Take off another 10 and bring it right to 60. And again, it's okay if we're a little bit off. Not a high precision part. Arguably, I could have done all this in a bandsaw. All right, let me go do the other side off camera and I'll clean it up and show you the final result. I think it came out pretty nice. Rounded off the corners a little bit with some sandpaper and some Scotch-Brite just so I wouldn't jab myself. So I think this thing is sized perfectly. Now we need to figure out where to drill the holes in here and in the cross slide to mount this bar to the cross slide. All right, so I've got this all mocked up here. So I ran the cross slide front to back and found the spot that gives me sufficient travel, but also doesn't leave this sticking out. I really don't want to risk hitting my hand on this when I'm turning the hand wheel. So that seems like a good compromise right there. I'm going to run it back and forth and just double check, but I made a red Sharpie mark there and there on the aluminum piece so that I know where to drill the holes between. So maybe I'll come in like an inch on either side and just drill holes there. I pulled the cross slide off the lathe just by unscrewing it. It's pretty easy. You might have to remove that back splash guard to allow it to slide out, but Really not that difficult. So what I did here is I used the edge finder to zero out the DRO on this edge and on this edge here. And I used the DRO to measure the length of this part. So what we did is I edge found, went all the way over here, used the edge finder to find this edge here, which came out to 9.535 inches. Subtracted 100 thousandths for the radius of the tool, and that brings the total length from here to here to 9.435 inches. And I confirmed that with a tape measure. It's pretty darn close. Well, the tape measure is close. This is dead on. So I mentioned wanting to drill the hole about an inch in from here, inch in from here. So we'll get that going next. We do need to figure out how far in we want to drill these holes too, in the Y direction. So in a perfect world, I'd love to hit this webbing, not webbing, but I'd like to hit this piece of metal right here. I don't want to drill into the T-nut hole. I definitely don't want to drill into the ways, so we'll target right here. So to hit that dead center, we can measure the thickness of this webbing. Close as we can, so 0.381 inches, divided that by 2, and add that to this thickness here, which is wait, is there a little lip in there? Or is that a scratch? I can't tell. Well, anyway, measure that distance, divide by 2, plus this distance here, and that should give you the center line of where you want to drill. And for this machine, looks like that's 0.6875. Oh, it looks pretty good to me. I know you guys probably don't have the best angle on it. And before anybody gives me a hard time in the comments, I don't have any soft jaws for this vise, and this is a very precisionally ground surface, so I put a piece of copper wire in here just to avoid damaging this machine surface. Copper is a lot softer, so that's acting like a soft jaw here. Just a little piece of like number 14 or number 12 copper wire. After considering things a little bit further, instead of going in an inch, I'm going to go in an inch and a half because I want to leave room to get to this gib adjuster lock nut right here. If this is an inch, it's going to be pretty much touching. It's going to be tough to get a wrench in there. So hopefully that gives us a little bit more room. Maybe I should test it though. It still could be a little challenging. Let me get a wrench. This is going to be on there flat, so we have enough room for a ratcheting wrench. I think. Do we clear the base though? Let's see. No, we do not. So let's try the open end side. And we're contacting that thing. Let's move it over a bit more. Let's say maybe 100, maybe another 100 thou. There's 1.6 inches. How does that look? I think that'll work. Yeah, I can make that work. So 1.6 inches in on this side. And some of you may cringe, but I'm going to try and drill both of these at the same time, just so we can make sure that everything is lined up properly. I'll have to clamp this, obviously. Okay, I think this sketchy setup is going to work. Now I'm going to zero the Z-axis. So I have the Y. Wait, no, I'm sorry. I have the Y set to 0.687. So should be in the center line of that webbing, for whatever you want to call it. The space between the T slot and the way. and we are in 1.6 inches to the left on the X. So this should be our first hole right about here. Now I'm going to zero the Z. I'm going to do this with, this is not a super accurate method, but for what we're doing here, it's fine, just drilling holes to approximate depth. I'm using a 20 thou feeler gauge. I'm going to raise the knee until I just start to feel resistance. That's right about there. So we'll zero the knee and we'll bring it up 20 thousandths, and in theory that should be right on the money. That's 19. Okay. Cool. Now we'll re-zero the Z. And now we can drill holes to semi-accurate depth using the knee. That's what things look like on TouchDRO. So again, we are over in the X direction 1.6 inches to clear those gib adjusting lock nuts. We are in that way on the Y to hit that center webbing in the cross slide. And we have our Z approximately zeroed. Again, it's probably accurate within a couple of thousandths. If you need something more accurate, there are other ways to do it, but this is accurate enough for drilling holes. So we should be good to go now. So I want to drill to a depth of about 0.7 inches, which should give us enough bite. It should give us enough bite for the screw threads with a little bit of extra depth. Now, could I have done this and drilled these holes separately on the cross slide and this bracket? Yes, I sure could have. I may regret doing this, I don't know yet. But this seemed like a fairly easy way to set this up. Not super sketchy, just have to constrain it in every direction. So it's constrained this way with these parallels. They're maybe about I don't know, 3/8 of an inch thick. And they are constrained, and the part is constrained this direction and this direction with these clamps on either side. They're wood clamps, but again, we're not machining, we're just drilling holes. There shouldn't be a whole lot of force on this part. Famous last words, right? One thing that I'm not 100% sure of is the screws that I'm using to fasten it are M6, and you can see that they're, I forget what the name of that head is, but it's a tapered head. I don't know if the tapered head is gonna clear. It looks like it might not. It's gonna be close because we have to countersink that. All right, enough talking. Let's get to work here. Get a little bit of WD-40 on this cutter. We're going through aluminum first. You guys keep an eye out for any chatter. And I'm going to turn the knee until the DRO reads 0.7. So hopefully you guys can see everything. Let's get going. See a chip forming. Back it out a little bit more lube in there, just using WD-40 since this is aluminum. Should start to see a transition into steel in about 30 thou or so. And now I should mention this is the tap drill. It's not the clearance drill. That's important. This is an M6 screw, so a 5mm tap drill. I think we've officially transitioned into steel. Let's back this out and clear off those chips. I don't know if that's steel or cast iron, actually. I'm not really sure what it is. Let's throw a bit of oil in there. Something a bit more appropriate for this metal. Pretty sure this part is cast iron down here. It's producing those really fine shavings that's characteristic of cast iron. We're almost to 1/2 inch, 500 thou. changed my mind, decided to go to a depth of 1 inch, primarily to account for, I'm not sure how thick those spaces are going to need to be yet. I haven't machined them, so I just want to leave myself some wiggle room with the threads. So could have trimmed the screws down, but that's a lot more work than drilling deeper. On to the next hole. I think I'm going to drill there. It's right between the 2 gib adjusting screws, so I think that'll do. And I dropped the light. That's awesome. And I think I broke something, even better. Cheap garbage. Anyway, so yeah, we're at x coordinates minus, or 7.75, give or take. So let's start drilling here. I'm just going to do this one off camera. You guys get the idea. All right, got both holes drilled to 1 inch. Now I'm going to switch over to a letter G drill to do a clearance drill only in the aluminum. So I'm going to drill to about, I don't know, 300 thou or so. Let's get that done. Already got that drill loaded up, did that off camera. Oh, I guess we need to re-zero, don't we? What am I doing? Jeez, can't let me do anything. There we go, just use the feeler gauge method to re-zero. So we're gonna go to 310 thou or so. That's roughly the thickness of this aluminum. It'll get us 99.9% of the way. We can always drill it out with a hand drill the rest of the way if we need to. If we go a little far and chamfer the cast iron, it wouldn't be the end of the world either. I think that's right about when the sound changed and we hit cast iron. So now we'll move back to our original position and we'll do the same thing. Okay, we're back at our original hole. We'll clearance drill this one now. The end of our drilling in the aluminum, hopefully. If we need to touch anything up, like I said, we can do it with the hand drill. Now let's take the aluminum off. Hopefully we got all the way through. Let's take a look. Yeah, we got pretty much all the way there. We can finish that with a hand drill. In my haste, we took the part out before I had a chance to chamfer it, so why didn't you guys stop me? Now I gotta re-zero all this and get it all set up again. Alright, I got the countersicking bit all jigged up there. Hopefully this is centered enough. It's not perfect, but this is just for a screw, so let's see how it works. I don't have this thing too rigidly supported because I can't get a clamp in here, so hopefully the cutting forces are not so high where this is a problem. Is this thing locked? What's going on here? No, I had this all... Yeah, never mind. See how this looks. Not very rigid. We need to constrain this a bit better. Not great, but let's see if it helps. Might be good enough. Don't be dumb like me and forget to do this. Oops. Put our depth lock nut here. And we'll pivot over to the other side and do the same thing there. Okay. All right, still a bit of a sketchy setup, but we'll do the best we can. It was a dumb mistake. You're gonna make mistakes all the time when you machine. This is the only one I make in this project, I'll be happy. Oh, I didn't have that centered. I just made another mistake. 775. There we go. I was not centered over the hole there. Let's try that again. Let me just make double sure. Yeah, 7.75339. Go a little bit more. Close enough. I'm gonna go slow since this is sketchy. Hear it? Hear it, sketchy? Oh, man. That's so dumb. I don't know why I did that. Might be the best we're gonna get. So we're overhanging a little bit, but worst case we can always grind those screws down a little bit. But that's the idea. We want them to be flush or countersunk slightly. Now if I had this to do again, I would probably use an M5 screw just so we didn't run into that same problem, and M5 should be plenty strong. So now let's switch out the countersink for a tap follower, and we'll tap these threads to M6. Okay, we got our tap follower in place. Bring the quill down to, I mean, this isn't the super best way to do this, but it works. Put a little bit of thread cutting lube on here. I'm not a big fan of power tapping personally. Some people swear by it. I am not one of those people. Probably just not good enough. That's the bottom right there. So this is a taper tap. I'll switch to a plug tap so we can go all the way to the bottom. I think that's all the work we have to do to the cross slide. Just got to clean it up real well and get it back on the lathe. Hope I didn't forget anything. I'm taking it out. Oh no, I forgot something. No wait, no, I don't think I did. I think we're good. Let me clean this thing. All right, let's get this thing back on. Get my 90,000 chairs out of the way. Squirt a little bit of oil on the lead screw here. A little bit of oil on the lead screw nut. A little bit on the ways. All right. got our gib adjuster here that we'll have to reinstall as well. Let me clean it off first. Okay, I got the cross slide installed and cleaned up. Used just a bunch of WD-40 to clean it up. It was pretty gross. Let's try these plastic spacers and see how things pan out here. It's the next day. I can't remember where we left off or what the last thing I said was, and honestly, I'm just too lazy to look at the video footage, but we got this scale mounted up on this bracket that we made. For now, I'm just going to use these 3D printed spacers. I think that's actually pretty sturdy. That's not going anywhere. I have this dialed in pretty well with the dial indicator to make sure it doesn't move. You know, it's parallel with this surface. Doesn't, you know, this side isn't higher than that side. You know, this side isn't sticking out further. If you do have issues with, you know, one side sticking out a little bit further than the other, they do provide some shims with the kit. So like, see these like horseshoe looking things right there? So you can use those if you need to space things out a little bit. But now I think I'm going to focus on what appears to be the much larger challenge, to make the bracket that goes in here to mount the reed head. So we're going to need to fashion something in there. And we're going to need to engineer adjustability into it too. I don't know how well I'm going to be able to film actually installing that, because that's going to be a bit challenging. Yeah, this is going to be tough. Let me take some time and mock something up, and we'll go from there. All right, I made a lot of progress off camera, and I'll show you this design I came up with on the lathe in a little bit, but I just wanted to show you how I'm machining these slots. So you notice a slot. Let me turn the mill off so you can hear. There is a slot here and a slot here to allow for vertical adjustability when I mount this bracket to the lathe. Obviously, quite a bit of adjustability, way more than I'll need, but I figured might as well cut them. I'm here. So what I normally do, I've got this side set, this part of the groove is set in from this edge, 0.3 inches, and I'm extending 1 point until the x-axis reads 1.1 inches. Again, way more adjustability than I need, but one thing that I do is I'll typically plunge down with the cutter, and then I'll go in either direction, just short of my target. So I might go like a couple thousandths short of 0.3 here, and then what I'll do is once I reach full depth, I'll cut the last few thousandths together, so you have that nice uniform edge here. If you do it piecemeal and just sneak up on it each time, there might be just like very minor like vertical grooves in there just from minor variations of how you're doing the cutting. It's not a big deal. That's just the technique I like to use. I know that cutting the groove with a cutter like this, how I'm doing, is going to result in a groove that's wider than the cutter just because of minor deflections, but it doesn't matter in this case. I'm using a 6mm screw, and this should be plenty for that. So let me shut up and we'll resume the cut. So I'm at about 260 thousandths depth right now. I'm going to go down maybe another 50 thou or so, give or take. Good enough. I'm just going to go this way, slowly. Nice thing about doing this off camera is I can run a vacuum so I can see what I'm doing, evacuate the chips. So I'm right around 500 thou, so about 200 thou to go. Again, I'm just going to try to sneak up on that 300 number on the x-axis. Another 15 thou to go. I might leave it around there or so, 4 thou shy. We'll go back in the other direction. We'll do the same thing. I want that x-axis to be 1.1. And I always plunge down in the center too, because I don't know about you, I'm not a super seasoned machinist. Sometimes I'll crank these wheels the wrong direction by mistake, and I don't want to do that and mess up my cut. I'll come just shy of 1.1 here. Maybe around there. Go back to the center. And then we'll plunge and keep on repeating. Pretty simple. So that bracket that you saw me make there, or that you saw that I made, is actually right down here, where my index finger is. On my lathe, when I had arrived, it actually had some markings where screw holes were to be drilled. Little oval holes. They must have, maybe that's part of the unpacking and prep process at Precision Matthews. I'm not really sure. So I think the next step, trying to decide if I want to take, I guess this is the saddle, right? The cross slide with this top piece, whatever you call it, or the carriage, the top half of the carriage off, so I can drill and tap those holes. I don't really feel comfortable going in there with a hand drill just because the ways are so close and I don't want to risk damaging them. And plus it's going to be really tough to drill a straight hole with this narrow clearance. So I'll probably disassemble the carriage, take the top part off, stick that in the mill, and mount it that way. One other issue I did notice as well is that the reed head, the holes on those are actually tapped. So I guess that means the screws are supposed to go in from the other side. I don't know. Not really sure why that's like that. Not really thrilled about it. I was hoping to put screws in from this side, so I don't know. Have to figure something out there. Okay, I used a 6mm center punch or transfer punch to mark one of the holes, and I know the spacing between the holes so I can calculate the other one in theory. So I think the next step is going to be to disassemble this carriage and take the top half of it off and stick that on the milling machine. That one is loose too. Maybe they're supposed to be loose. Don't exactly know what they are. Okay, so this bottom half is dropping down. Let's clear everything out of the way. Maybe get a block of wood to put under it. Two 2x4s are just a little bit too thick, so I'll hold it while we unscrew and kind of hope for the best here. You can see how loose it is. I'll take one side off at a time, maybe. Here's like me, I might only have to take out those front 4 bolts. So is this thing gonna fall? Maybe not. There, it's resting on the hammer handle. Maybe we can just lift this piece off now? Oh, I probably need to remove the lock. Doesn't really seem to be much hole in it. Taking out the gib block on this side. This is that bolt that I had replaced with a hex head screw. That may now allow us to lift this off. I don't think there's anything else holding it on its own mass. Sure feels like there's something holding it. I don't see any of the fasteners. Aha, I thought I remembered a couple of screws under here. I guess these are probably the gib adjuster, right? Is that what this is? It's gotta be. And they are filthy. It'd be a great opportunity to clean everything up. And that's probably the gib that just fell down. Yep, here it comes. It looks like all these screws are the same length, thankfully. probably will pop up. Yeah, so now it comes up. Not quite. There might be something on the back. This came out exactly like so. I'll put these screws in the orientation, just so we know for later. Again, right here. Feels like there might be a similar piece on the other side, but hard to tell. Okay, so on the back, it feels like there are some Allen screws that are held in place with lock nuts or jam nuts, much the same way the gib adjuster on the cross slide is. I'm not going to be able to get you a shot of that, but they're right along the back side back here. So let me see if we can get one of them out and show you. Okay, they're smaller than an 8mm. They seem to be 7mm. I cannot remember the last time I used a 7mm socket or 7mm tool of any kind. It's loose. You guys are getting a picture of my arm. This is where accessibility in the back is a big plus, and I do not have that luxury, unfortunately. Let's see what size. Hex screw, maybe a 2mm. Let's try a 2. Jam nut. That nut doesn't spin. All right, so I guess you could just take them all out with a 7mm socket. There are 1, 2, 4 of them? 5. Okay, things are starting to come apart. So once I took out that last gib adjuster screw, I just rotated and slid this to the right, and the gib is right here. Will they burn that with a torch? I don't see any obvious orientation marks. I'll stick this up here out of the way. So now in theory, I think we could just lift this bad boy off. Yep, there it goes. She's off. Get this out of the way, and then we'll get you guys over to the mill. So that's what things look like inside. I don't know if you can tell, but there's a puddle of oil down there. I don't know if that's oil that I put in there when I oiled the machine, but there's no like instructions that say that that's a gearbox that needs to be filled with oil. I can't feel a drain plug or a fill plug anywhere either. So like, what's the deal there? Is there supposed to be oil in there? Should there be more oil than that in there? I don't know. This is the underside of the carriage. So this is where the gearbox was that we just saw. This is where that gib strip went, right here. These are the 5 screws we took out. What is all this? It looks like someone hit that with an angle grinder. Wow, what horrible, horrible machining. I mean, normally though you'd expect, well, nice machine, these would be hand scraped, but these, it looks like someone just hit this with an angle grinder. It's not even a smooth surface. That's pretty disappointing. Anybody from Precision Matthews sees this, what's the deal? Is it supposed to be this way? Typical of what I've heard from Chinese machines, this thing is absolutely filthy too. Doesn't seem like any attempt was made to clean it up. Again, disappointing. We'll clean it up real nice before we put it back together. Just getting the obvious stuff out, like pieces of paint. The metal flakes could be me. Back to the project at hand. These are those factory drawn oval hole marks that I talked about earlier. And there's my center punch mark right there. So we'll drill and tap that. This looks like cast iron. It shouldn't be too tough. And then what I'll do is I'll move over, what was it, what did I say, 1.1 inches, and we'll drill and tap another hole right there. We're going to take the way wipers off first, just so this thing can sit flat in the mill. A couple of Phillips head screws. Barely even tight. Worth mentioning that this is a cast surface, not a machine surface, so it's probably not going to sit perfectly flat here, but it's going to be flat enough for a couple of drilled holes. You know, if they're a little bit off vertical or not straight, it won't be the end of the world. Okay, I've got the saddle chucked up in the mill. Got everything zeroed out by eye. I used a center drill in the drill chuck, and I just used a magnifying glass to get to align as best I can the X and Y direction on that center punch mark. So let's go ahead and center drill this. I'm not going to show you this whole procedure. It's pretty similar to stuff we've been doing already, but I'm going to center drill that hole, drill it through, tap it, move over. I think it was 1.1 inches. Keeping the Y-axis the same, just going to move over in the X, drill and tap that second hole. We'll just bring the Z up just so you guys can see a little bit better. And I'll drill and tap this much like I did the other holes. Okay, I got both holes tapped and drilled. I don't know if you guys can see that on camera, but I'm noticing this surface isn't perfectly flat. I think I mentioned before it's not a machine surface. So what I'm going to do is I'm going to scribe the outline of the part here. I'm going to take an end mill and just carve out some space in between to make it nice and flat. I'm not going to go nuts, just going to true it up just so it's sitting level. That may change the spacing between this and the reed head, but if you recall, I didn't make those plastic spacers out of aluminum yet. So they're still 3D printed parts, so I can dial those in to get the clearance just right. So we can always go back and adjust that if we need to. So we can see our scribe marks. I'm just going to go ahead and touch this up with this end mill here. So I just touched off at the lowest portion there. I'm going to slowly just move things, flatten this surface out. Don't want to remove as little material as possible. I'm going to continue with this, do it off camera so I can vacuum up the chips. Didn't really end up needing to take off too much, maybe 10th hour or so. I'll probably have to remake those spacers, but again, no big deal. It's 15 minutes on a 3D printer. Let's deburr these guys a little bit. test fit our bracket. I know these screws are too short. I'll get longer ones. I'm not worried about that right now. Actually, it may not be that short. Did I say they were too long? Man, I'm losing my mind. I meant too short, but they may not be too short. No, this thread's come out the back. They're perfect. So something like that. I know these slots are too long. That's fine. You know, this is all made out of scrap materials. It's not something I paid a whole lot of attention to measuring wise. I just want to make sure it was going to work more than anything else. I could be way off on this, but I'm going to suck this oil out of here. And one, I'm not sure if it's supposed to be in there. And we'll put some, I guess, some better stuff in there. Doesn't seem like there's a whole lot, though. Very minimal. Okay, so I think that oil is supposed to be in there. It turns out one of those ball oilers on the top drops directly into here, maybe just directly under this gear. So I think we're okay dumping some oil in there. It's probably not a bad idea anyway. It's being a lot easier to pour it in there now than through the ball oiler a little bit at a time. So let me get some Vactra number 2. I think that's what this machine is supposed to get. Clean up some of this extra grease. There we go. I'll just dump this Vactra in here. Wasn't much in there, maybe a cup. At least now we know everything is lubed. And if we develop an oil leak, we know where it's coming from. Oops, wrong hole. Just noticed these parts on the ground. Probably need to figure out how to get these back in. Fun. Alrighty, back at it. I switched these spacers over to rectangular spacers because the circular ones were actually interfering with this bracket that we built down there. So I have moved everything through its full range of motion. I don't see any interference. I don't know if you guys can see, but the bracket's down there. Everything seems to be doing fine. The final step in this is to fasten this reed head to that bracket that we built. So I have to use my center punch and punch some holes and drill and tap those. Fun fact, remember I told you that I was going to fill this gearbox with oil? Don't do that. I guarantee you it's going to, well, at least in my case, a lot of it leaked out. So don't do what I did. Learn from my mistake. Don't fill this with oil. Just keep a little bit in there. I did screw up a little bit though. The Z-axis here, that DRO scale that I bought, I don't know what I was thinking. I can machine things to within 1/1000 of an inch, but I can't. Somehow I measured 4 inches off with that one, so I ordered one that was too long. So got a new one coming, so we're not going to be able to do that. That might be a part 2 video because this video is probably long enough. But let's center punch this, get this mounted up. I think I called out last time that the threads or the holes in the reed head were tapped. I'm not going to really take advantage of those. I'm just going to use, I think they're tapped for M4. So I'm just going to put a smaller screw in there and just basically bypass the threads and tap the bracket that we built. I think that's going to be a better arrangement for us. So let's go ahead and transfer punch this. Let's take our bracket off so we can drill it now. I deliberately used hex screws here, external hex, because not a lot of room to get an Allen key. I figured this would be easier. Just as a sanity check, I screwed, these are actually M4 threads, or no, they're M5, not M3. Well, they take an M5 screw, but I'm going to use an M4, which should go straight through the threads and not catch them. But anyway, I screwed some M5 screws in here to check the hole spacing here. So I measured the outer distance and the inner distance and averaged them, and I got 2.3485 inches. And then I set my caliper to that number, and then I went to the mill just to check my center punch marks, or transfer punch marks. And you can see that is dead on. So that's perfect. So we'll actually use the DRO to drill that second hole. And I'm trying to think how I want to do this, because these marks didn't come out perfectly. They're not perfectly aligned on this axis here. So I think we might just drill one, and then you keep the y-axis on the mill the same, and then DRO over to 2.438 inches, and then drill the second one that way. I think that might be the best bet. All right, I lined up by eye in a magnifying glass the hole on the left side, so I'm going to zero the DRO on the X and Y. Reason why I'm doing Y is just in case I kick the handle, I can see it up here that it moved. So I'm going to center drill this. Change out our center drill for a 3.3 millimeter drill bit, which is the correct tap drill size for M4 threads. And we'll just go ahead and drill this through. Okay, that's all set. Now we'll move the DRO over. What did I say? 2.348. There we go. Looks nice and lined up. A little center drill. And then drill this one just like the other. There we go. Both mounting holes drilled and tapped. Did have a little bit of a snafu on this side. I misjudged this right here. Didn't realize that the edge of this part was right up against this. So mistake on my part, but not the end of the world. Things seem to be lining up nicely. I just picked two 4mm screws out of the bunch. Even got lucky and they were the right length. Now this slim scale didn't come with any like alignment strips or anything like that, like the larger scales. I don't know why. So we'll just kind of do it by eye, and hopefully we do a good job with it. Maybe what we'll do is we'll just try that. So let me just tighten down these bolts that hold that bracket in place. Like I said, most important thing is make this adjustable, because you're gonna need it. How's that look? Seems like it's working. I kind of like this design. I can still get to all the important parts of the lathe. The only thing I can't get to, I think I may have mentioned this before, there's a ball oiler directly below this rail, but I can oil that way very easily by simply cranking this handle. It's a little annoying, but you're not going to be oiling these things multiple times per day. If you are, you probably need a different lathe. So if you get it to where this cavity is exposed, that groove that you see on either side of the lead screw, that's the way. So I just need to squirt a little bit of oil in there like that. That's it. Good time to oil the lead screw while you're at it. And crank it back. So really not the end of the world. I could still get at the gib lock pretty easily. I think that's going to be it for part one, only because I don't have the parts for the Z-axis DRO scale. I need to order the right size. Hopefully you found this video helpful. Hopefully this can help you install the more challenging DRO scale on a Precision Matthews 1228 lathe. There's not a lot of space here. We didn't lose a whole lot of travel here. We can still get at all the gib adjuster screws, so like I'm pretty happy with this. I think this came out nice. Anyway, hopefully you found this video helpful. If you did, please subscribe. Stay safe. Thanks for watching, everybody. Take care. And don't forget to stay tuned for part 2. All right, guys, I lied. I skipped ahead. There was absolutely no way I was going to be able to film installing the DRO on the Z-axis, so I figured I'd show you after the fact. So I got a nice long scale. I used the bracketry that came with it. Let's get this guy out of the way. So I used the bracketry that came with the DRO kit. You can see those 3 brackets here, here, and down below. Wasn't really too bad to install. It was just an awkward spot. And I printed some spacers with a 3D printer, about 300 thousandths thick, to go between the actual DRO scale itself and the mill casting, because it's not perfectly straight. I'm sure the 3D printed parts aren't perfectly straight either, but they give a little bit. So I got that all set up there. I got both DRO scale cables going into TouchDRO up here, so now it's time to calibrate it. I did get it hooked up to the milling machine tablet for now until I get a tablet for here, and I confirm they both work. In case you don't believe me, moving the Z-axis now, and moving the X-axis now. So now we need to follow a procedure to calibrate these, because right now I think they're moving in much larger increments than they should be. All right, I got everything calibrated in. I'm not going to waste your time showing you how I did it, because I basically just followed another YouTube video. If you go to YouTube and search for TouchDRO calibration, you'll find some great videos on how to do it. So next step is to mount the TouchDRO box, which is right here. And it has those little keyhole screws in the back, and I'll show you a little trick for getting those drilled perfectly every time. Take some blue tape and put it over the holes like so. Find the indentation of the keyholes with your finger. So we got there, make a hole with a pencil. There you go. Now take that tape and put it on the surface that you want to mount it to. So I'm going to mount it on the underside of these shelves I have here. So maybe right under there on the plywood. So I'll mount it, do that off camera, and I'll show you what it looks like. All right, so that's our finished product. I got TouchDRO, well, I got the scales mounted on the cross slide and the carriage. So I have both the X and Z directions. I was able to 3D print a tablet mount. Just pulled this off. I think it was either Thingiverse or Makerworld, I can't remember. Threw that together in the printer. Still have to test it out to see if that actually works here with vibration and everything. Got the TouchDRO mounted up here out of the way, out of the path of the spinny death wheel here. So yeah, everything seems to work pretty well. So I turn the crank, numbers change, they change the appropriate amount. So I think that'll do it for this video. So if you found this video helpful, please subscribe, stay safe, thanks for watching everybody, and hopefully this will help you install TouchDRO on your Precision Matthews PM-1228. Have a great day.